Because Brewhoof has got it wrong. I'm telling you.
Well, he didn't know we were talking about 16 thermocouples at ground level.
Speaking of pressure gradient, how's that work on a flat Earth with no gravity?
Oh, like density?
No, like the pressure gradient.
You mean how like heavier things will sink and lighter things will rise? Is that what you're talking about?
No.
No?
Yeah, pressure gradient.
Okay. Well, then I don't know what you're talking about.
Okay.
I thought heavier things sinking would cause a pressure gradient
Why would that cause a pressure gradient?
because the things that were sinking would be under pressure from the things on top of it.
Do you think that air has weight?
Jesse measured that air has weight.
That's why we have
So-
pressure.
Yeah, I put 5 gallons of air in a pot on my scale, weighed it. Then it was a vacuum pot, and then I used my vacuum pump to remove the air, and I weighed the pot empty, and there was a difference, just what it should have been.
I did the same thing, but I filled a scuba tank to 200 bar. It was a lot of weight.
Like 6 pounds, right?
Yeah, about that.
I'd used that argument before, but the response came back from way too many people saying that the air was a liquid in the tank and that liquids are heavier. And I couldn't figure out any way to convince them otherwise, so I weighed air at atmospheric pressure, which is clearly not a liquid.
I mean, slosh the tank around and see if you can feel liquid sloshing around.
Yeah, I know, but some things are just a hard sell.
So if we're admitting that air has weight, and that's what causes pressure, I suppose this is not a contained crowd, right? No one here thinks that it was a container. Because that would be silly to hold those two beliefs at the same time, wouldn't it?
It'd be pretty silly.
Oh, could you repeat that one more time, please?
You don't need a container if air has weight.
Oh yeah. There's two theories, right? That as if you have a cup with a lid or without a lid. So I guess the globe defenders would say that there's a cup without the lid, so there would be no container.
Want to say that again? Sorry.
Well, okay, on the biblical model, there's the firmament, so that would be the container, the lid, and then on the globe, there's no
Just to be
lid.
clear, there's no evidence for, nor
For
any
the firmament?
requirement for. Yeah, no evidence nor any requirement, right?
How do you know?
Well, the government definitely found the firmament, the U.S. government. I don't think they're sharing that. I believe that's a state secret.
How do you know? How do you know? There's no firmament.
I
There's
didn't say there's no firmament, I said there's no evidence of a firmament, nor any requirement for there to be one.
How do you know?
Do you have evidence of a firmament?
You're asking me how I know there's no evidence for something.
Taylor, have you seen evidence?
I'm not
for the
aware of
firmament?
any evidence.
You
How
know
about
one's
that?
required. That's what you said.
Well, because we've all disagreed that air has weight, and that's what creates pressure. And if that's something that you can accept, then you don't need a firmament, right?
Can you show a pressure gradient without a container?
Yes.
Okay, post it.
Well, I drive to work every day and I go down like 1,000-foot hill. At the top, the pressure is like, I don't know, 30 or 40 bar less. Not bar, sorry, millimeters of mercury less than it is at the bottom. And there's no container around that drive down the hill.
Yeah, but you can have a pressure gradient within a container. That's fine. So if somebody believes in a firmament and you don't,
Yeah, well, so
Is it
the
pressure gradient
answer. Well, yes, there is, and there is a continuing pressure gradient. So the answer is there is. If you accept that there is a pressure gradient because of the weight of the air, there is no requirement for a container.
then model that out, Jimmy.
Many people have, right? So this idea is that if you have a pressure gradient, that's the result of the molecules like air having weight, which it sounds like we've all agreed that there is, right? Then the air molecules that are lower, like nearer to Earth's surface, are in a lower energy state than those at higher altitudes. So the equilibrium state of such a system would not be uniform density, but it would be a pressure gradient, right? This minimizes the total free energy of the system. This is the state of maximum entropy, considering the forces you observe, right? If you observe that air is affected by a downward vector, e.g. it has weight, then a system with a pressure gradient tapering off to a vacuum is the lowest energy state of the system. It's exactly what you'd expect. So there's no need for a container. In fact, there's no reason to even assume there would be one at all.
Okay, so how much in your understanding is there a loss or a transfer between space and the gases on Earth?
I suspect you know the answer to that.
Well, yeah, I think it says 50 million tons. I'll have to double check. But so do you believe the system is exchanging between space and the globe? Because, like, for instance, on the globe model, right, I think Earth is losing specific gas, right, at the tapering point. Am I mistaken?
Yes, Earth loses gas.
Okay, thank you. What do you think resupplies? Is it maybe from the globe, like maybe the volcanoes, or do you think it's from space, like the sun?
I don't think that it's being strongly resupplied. I mean, you have gas that's created by some geologic processes, but I don't think it's a ton.
I think it's from
I
the sun.
think you're just overestimating how much gas we're losing.
Are there, like, you guys having a debate together? Or can other people talk? I'm just wondering. I don't want to interrupt if you guys are talking.
Yeah, jump in, bro.
Okay, so I think so the sun's going to hit the Earth and then it's going to cause photosynthesis and everything, and then you're outgassing and all that. So I mean, I guess it would all come from the sun, right? It
But
just
the sun
replaces it.
doesn't create gas.
Well, the sun doesn't create gas, but it creates gas through things that it stimulates, and they think they make gas.
No,
I guess.
No, they don't.
The sun doesn't make gas.
Where does
And I know the sun doesn't make gas. I'm not saying the sun makes gas. I'm saying that.
Neither does photosynthesis. Plants don't make gas either.
they
I know,
take in-
but I know, but then an animal eats the plant, and the animal dies, and then there's gas made from that. I mean, I'm talking about like down the line. I mean, the sun's creating the gas.
There's a cycle. It's not creating. There's no creation of gas here. There's just a cycling of gas.
Well, if so, what?
I mean,
Does anybody know? Does anybody know how the Great Oxidation Event happened? How did Earth get all the oxygen?
From like single cell organisms shitting in their gas.
Oh wait, where did they get that from? They had to have it. They don't just make oxygen.
Earth started with an atmosphere, just not an oxygen-rich one.
Wait, so how did the oxygen come about?
He just told you.
Where is
it
carbon
made?
made?
Yes. Can you tell me that process, like how that happened?
Decay. Something.
What?
The thing is, like, okay, so gas comes from decay. I think.
No,
If I
it's
think about
cyanobacteria.
it,
No, it's cyanobacteria.
okay, but
Cyanobacteria. What did they
Sorry.
do? What did they convert to make oxygen?
I'm not a biologist.
yeah.
Don't
So
they say that all the elements on the periodic table were made inside of stars? Isn't that
Except for hydrogen,
like?
helium, and a little bit of lithium.
So where's the oxygen being made?
Stars.
it's a good question.
So-
It is. It is a very
Wait.
good question.
So the plants absorb the CO2 and emit oxygen. Does that imply that plants are now creating the element of oxygen, or is oxygen still made inside of
What is CO2?
the sun?
What is CO2?
Carbon
Carbon dioxide.
Okay, so what's
It's
what does
dioxide.
dioxide mean?
Okay.
Yeah, we want to know that process that happened by, especially if it
It's a breakdown of oxygen after it's been like processed through some organism and then expels. It's like the waste. It's pretty much oxygen. You know what? It's a good question.
No, this doesn't make sense. This doesn't make sense, man. I know I
No,
screwed up on the dioxide part of things, but it's still like it's bringing in carbon and emit like
This makes perfect sense. What you're talking about is photosynthesis. It makes perfect sense.
wait, where did the carbon dioxide come from?
H12
Cool story.
O6 plus CO2
Where did the carbon dioxide come from?
plus light goes to O2.
where's the carbon
and the
come from?
oxygen? The carbon and the oxygen came from stars.
No, where did the carbon dioxide come from?
Presumably
Well,
geological processes.
You want to know why I asked? Because they assume a
Not really.
reducing environment for early Earth.
Yeah, but I mean, when we're having a conversation like this, it's either a reduction or regression. Like, I mean, yes, it's fun to trace it back all the way to the beginning, but this stuff is here now, though. It's here. It's here. How do we use it? How do we adapt to it? We've already learned that shit. You know, it's like.
Sure, as long as you don't claim it came from there. As long as you don't claim that it came from there and turned up here, we're happy to like really just deal with the here and now, right?
Yes, as long as no one claims that they know how it got here. You know? I mean, they don't know. There's
I'm really
Yeah,
sure.
how it got here.
If people pointing that.
some people do. Some people don't. No one really knows. No one actually 100% knows where it all started from.
100%? No, but we have good evidence.
Yeah, of course, evidence is great. Yeah, I'm down with that, and like I agree with it too. The evidence all points to where we're at right now, and I'm down with it. It's just the whole thinking about where it all started from. I mean, we're talking about something that no one knows and no one can know. So when you talk about it, it's almost like you're spinning your wheels in mud. You know, like no one's gonna have an answer.
Don't agree with that, right? That's not how science works. Science is
No.
about collecting evidence that favors or disfavors hypotheses. And if you have a lot of evidence, I think it's reasonable to assume you might be onto something.
Yeah, but that's where this all where we're at right now. The progression through our knowledge has brought us to this point. I mean, there's one person thought the exact same thing that you said, that she said about where's oxygen come from. Someone had that thought a long time ago, and then a bunch of other people got together, and then they all combined all their knowledge, and we're to this point now to where this is, I think, the closest we have to where it came from and how it happened. You know, I
Yeah,
mean,
this is because the early Earth would have needed a reducing environment to make these organic compounds, like for
That's
the
true,
Miller experiment.
yes.
But then, wait, what?
Yes, that's true.
That's true. So then what? So then we have this oxidation event happen. And if that happened from CO2, CO2 would need to be present in small amounts in order to have that reducing environment. So this seems contradictory.
but it happened though. So that's the thing that we're.
But it happened. We should wonder how.
Yeah, but should we wonder? Should we spend more time wondering how it happened, or knowing that it happened and then working on things to make it to
We
understand
should
it better?
wonder why it happened, bro.
Yeah, but why would you want? That's like, okay, so I had something traumatic happen in my life or whatever, and I got it. I cannot get over it. I'm just gonna sit there and keep dwelling on my past my whole fucking life till I'm dead. You know, I mean, you never went forward. I know something bad happened in my life. You know, then you just go from there and then deal with life. And there's no reason to keep going backwards.
Yeah, there is. There's a reason to wonder why we got here.
That's
There's
not
definitely
history.
reason to go backwards, man. Because people make wrong turns all the time, and you need to go back and retrace your steps to work out where you went wrong.
Yeah, but don't go all the way back to the beginning though. I mean, like the beginning
Yeah,
of
yeah,
how it started.
You could have made a mistake way back then. Yeah, for sure.
Well, yeah,
I mean,
but, sorry.
neither of those ideas really have any bearing on the idea of a firmament, right? Which is what we were talking
Oh, we're
about.
talking about the firmament. Yeah, okay.
Oh,
we'll
my
get
bad.
back to that.
Black
my
layer
fault,
of,
guys.
I think I got the best reason why you should be thinking that there might be a surface up there. You want to hear it?
it better be good.
Sure.
Definitely.
Okay, so if electricity, right, flows through the air, we've got like wireless, charges, right? In order for any of this transmission of electricity or energy, it has to have what's called two Gaussian surfaces. Now, we definitely know that we have an electrical voltage gradient up into the sky. Where is that coming from? We've got the ground, but the globe doesn't have a second surface. It sits up in the sky in order to create what is essentially required for the transmission of electricity, which is completely observable and undeniable. So where's the second Gaussian surface, guys?
Well, okay, but when you have a motor, it's got to be something coming from the Earth. It has to be coming from the Earth, radiating out.
No,
It
no.
doesn't have to be, but I
The
think
voltage is high, up high, and it gets lower as it comes down to the ground.
Yeah, exactly. Yeah, I mean, yeah, okay, yeah. Either way, it's unless you're thinking, unless it's the sun. Well, no, I mean, like I like the whole fact that there's a core spinning because it's a motor spinning and it causes magnetism and everything. You know, I mean, it makes sense. It's like a motor. If you have something spinning and you have the right conditions, it would cause a field.
But you don't need to.
That's the ground and inside the ground and underneath the ground. I'm talking about up in the sky, you've got a voltage differential. We can't use what's inside of the Earth to sort of suggest that there should be an electrical current there. It's not within the two surfaces that I'm expecting.
Okay, well,
You don't need two
magnet?
surfaces.
You don't need two surfaces. You don't need an antenna
No, a point charge will have its own electrical field. It doesn't need anything else to have that electrical field. It'll be a perfectly radial field. The Gaussian surface is if you want to have a surface, the Gaussian surface. A surface is required if you want a charge that is a field that's parallel. You need two plates effectively to make a parallel field. The Earth's field is neither parallel nor uniform.
Yes,
It's
you can tell that. Yes, it'd be easy to see that. I'm sure. Like, you could probably
you can measure it, right?
Yeah,
By the time you
and
get
it's
to
like a magnet
Where is the electricity in the sky coming from?
from the Earth and the sun.
So
we have charges in the atmosphere and charges on
Sure.
the ground. Yeah. So it's an electrically volatile environment.
Well, you gotta think like a magnet. Okay, you have a magnet and you have it on the ground, and then you have a bunch of metal shavings. Well, wait, you have a bunch of metal shavings, and then you can push those metal shavings not to touch it, but it's like an inch out, and it'll start affecting, like it'll start sucking to it and stuff. You know, not sucking, but you know what I mean, attracting to it. There was nothing in between there. There had to be though. You know, it didn't have to touch the Earth to do it. So obviously that magnet was creating something around it that brought it to it. Same thing, I think, in a way that the Earth is causing. You know what you're talking about.
Just want to clarify one thing. When you have a wireless charger where it's charging through the air, are we suggesting that electricity is passing from the wireless charger through the air into the battery? Is that what they're saying?
Yeah. Well, it hurts.
they claim electrons are moving through the air, basically. Yeah.
No,
Yeah, if you can capture
what's happening.
If you can capture the
wireless
electrons that
charger.
are, if you can capture electrons that are vibrating at a certain hertz, then those will be attracted to it, and that would charge the battery. That's why they have the hertz. Like if you could have a proper charger in the middle of your room, and you had like 20 whatever hertz, all the electrons around there that are in that frequency would suck to it and then charge it. I think that's what it is,
You
right?
don't think that it's induction or anything like that?
Well, you have to touch it for induction, right? Like you have to have something actually touch something to cause a. Well, I guess all the molecules and particles are touching, but I thought it had to be like a direct touch, you know, like on your stove.
No, I don't think so.
I don't know. This is all just me. Just like took a couple hits of weed and I'm sitting here thinking about crazy shit. So
Apparently, carbon dioxide isn't even stable in a reducing environment, so I'm not sure how we would make that transition in this reducing environment needed for life.
Is it my God, that was the weirdest sidestep. Did anyone else see that, or have I
Yeah.
I was talking about that earlier.
we were just talking about electricity and then just bounced off to say totally different. That was
I'm
really
sure you did.
Yeah,
anyway,
yeah.
these guys.
It's a dynamic environment, man. Deal with it.
Yeah, it was a previous topic.
Oh,
The wireless
Electricity
charger.
was the sidestep. If you guys want to talk about electricity, I'd be happy to do so. But
Yeah, you're
Taylor
right.
was getting into that. Other
This is my fault too. It was my
I was
fault.
just doing the same thing, Andrew.
Help me out, Andrew.
Hey,
What's
Andrew.
going on? Why do I think that there's another surface in the sky, and these guys are saying you don't need a second surface for this electrical potential voltage that we see within the atmosphere and the
I'm
altitude?
not trying to sidestep or even jump into the main topic at all. I'm just saying that Taylor was talking about that, and people were neglecting everything she was talking about.
Okay, but to be fair, like everyone heard what she was saying, and then this conversation verged to where we are now. So,
Okay.
I mean, I'm just saying that's just what I gathered from it.
I don't mind.
So,
You guys can change it if you like. It's up to Taylor though.
I just
She
wanted
jumped. She told me over here.
Earlier, and we don't have an answer for it, so that's okay. We'll leave it at that.
Yeah, no, and we said that too. No one has an answer. I even said that. No one has an answer. It's just we have ideas, but
Were we done with the difference between molecules and atoms?
Yeah.
So I wanted to say
Water's
that,
not a molecule.
mic check.
Go ahead, man.
Oh, good. You do not need a surface to have an electrical conductor. For example, liquids can be electrical conductors, and plasma can be an electrical conductor. And I found this out as a child when I took the propane blowtorch and pointed the flame into the bug zapper, and electricity traveled right down the flame and zapped me. I only did that once.
How cool is that stuff, eh?
And
Yeah.
the ionosphere is said to be have a high level of plasma in it, so and is said to be conductive. So
yes.
So you're looking through plasma all the time. When you look up in the sky, you're looking through plasma, right?
Yeah, there's
Yeah.
a plasma sphere. Isn't that weird?
Yeah, I
But
know.
there are also
Like a cir-
gases. Just gases can be conductive.
you know, I missed.
Okay, so just to clarify, as far as conductivity is concerned, what Jesse just mentioned, my dispute was never about the conductivity. It's like, where is the energy coming from? And we obviously know it's going through the Earth. Like, no one's disputing the Earth itself. I'm not challenging conductivity. I know electricity can travel through the air. The question is, where is the source? You guys say it's inside of the Earth, and then it goes up, out, down, around, and then gets pulled back down into the Earth, and that's what we're measuring. The issue is not conductivity. The issue is, where is the energy coming from?
So
Okay,
the-
cool. Cool. So what do you guys have? Like, because we have that theory. Do you guys have a theory that we can judge against it? Because it's not. I mean, we have our theory. Do you have a theory we can weigh it against?
So
Well,
one source of energy is the sun. So the sun
no, because
is
it's very nice.
radiating. Yeah, it is. The sun is radiating charges. and those are do hit the atmosphere.
I mean, at night. You're saying that that's still present at night. So what is it, wrapping around the
No,
Earth?
but your chicken in an oven that is turning is also not only on one side crusty; it's on all sides crusty.
It's in an oven, bro. You're talking about a directional.
The Earth is rotating, and the atmosphere is hit by charges, so it's charging up. Or if it's hit by electrons, I have to look it up. It has negative charge, so and it's turning. It's not suddenly losing that charge only because it's on the night side.
Interesting.
How do you know the Earth's rotating?
I used to believe that.
Okay, could we stay on one topic?
That was a good analogy, though, honestly. Like, seriously, because even when it's rotating, the other side's still being cooked as it's rotating. It's just not
No,
direct,
it's
you know?
I thought the atmosphere
The oven's hot. The oven's hot.
Then
You're cooking it.
No,
is
the
it
atmosphere
capacitive then?
moves in lockstep with the Earth, though, so that would make sense.
Hey,
That's why
Brixby,
we
there's
don't,
about
we don't start flying over.
Yeah, that was a
about
good analogy,
100
Risky. It's a bit like a capacitor, that the atmosphere is charged up. There's the ionosphere is one source of charge, and the Earth is the other source. There's no physical surface at the top, but there is a high concentration of charge in the upper atmosphere.
Would you
And that is,
would you
as the other gentleman said, driven by the sun.
Would you say, like, from one side to the other side, from day to night, would you expect that voltage to go up and down? Or are you just suspecting
Yes.
that it evens itself out over the course? It kind of doesn't.
It's measurable.
It does a little bit.
Properties of the ionosphere change, right? And the atmospheric electricity does vary with on the day, I believe.
So
Well, if you get a wire-
the atmosphere is slightly conductive. So the electrons that are hitting our ionosphere are slightly moved towards the Earth. But it's the same like an isolator. Like if you're heating up your house, only because it's night, it does not suddenly just from now to then be cold in the house. It's constantly getting colder because your walls are an isolator and they let out the heat only partially. And the same happens in the atmosphere. So the atmosphere is hit by electrons.
Insulator.
They are flowing slowly. Yeah, an insulator, sorry. They are flowing slowly from the top to the bottom. So that, and that's why it's still charged upwards. You still have higher negative charge in the ionosphere than close to ground. And cloud movements and other movements of air also charging areas. For example, like what you experience with lightnings. So clouds moving, air layers moving towards each other, exchanging electrons, charging one part negative, while the other part is charged positive. And at some point, those charges are discharged.
Yeah, like friction. Yeah, you're talking about like friction pretty much. Yeah, they're all interacting with each other and then they just explode or there's energy. Through the lightning, I was talking about the lightning part, but yeah.
And the electric field doesn't require charges to move from one place to the other. Just the presence of charge generates an electric field.
Oh, I thought it was always
Like a magnetic field.
friction. I always thought it had to do with like when they bump. I guess heat is when they bump. Oh, never mind. I'm still really like not all that smart about this, but it's fun to talk about.
Yeah, there's a lot of lightning strikes every second. They say about 100 lightning strikes every second.
Yeah,
That's about correct, according to the National Geological Survey and
There's
the
ones you
National
can-
Weather Service and NOAA. Yes, that's about correct.
Yes. There's
So
ones you
these
can't see either too. You know.
so these electrons are hitting the atmosphere. They're all bulked up there, and for some reason they the electrical storm comes along, seems to gather all the the clouds are only up like what, a kilometer or so, maybe less. Particularly like storm clouds, and like all that potential energy in that storm cloud gathers up, and then it releases all of a sudden down to the Earth. Something's going on, man. Something's not making
Yeah,
sense to me.
definitely going on.
Yeah,
How
electric
do we
Earth.
get radio waves bouncing off of non-solid objects? Can we demonstrate that?
That's a good one
You
too.
can.
What again?
You
What
know
was
that
it?
radio waves interact with electric fields.
Well, if you like,
No,
you have
we need radio waves bouncing
Well,
off
yeah,
of non-solid objects. Can we demonstrate?
well, you have a highly dense area around our globe, and how would you? Okay, so like you're
Highly
flip
Stop
like
taking the question with the globe. Just go with your point.
I am going by point. This is what my analogy is. You got a stone. It's probably a better analogy. You got a stone. You throw it at the lake, and it skips, but it gets to the point where it just goes through. That first skip, I mean, you're still hitting it off a liquid, but it acts like a solid. I think that's what
Like the
gases can do too.
water's above?
Gases can do that too.
Bro.
What?
The water's above. We gotta
No.
figure it out.
No, I'm talking about like
So-
you can skip things off of non-solid. Like, I mean, you throw a rock at liquid and it'll skip across it. That first skip that would be like the radio wave hitting it and bouncing off.
I want you
So
to
you
show me a
want to-
radio wave bouncing off of something.
You want a different example of radio waves being reflected by a gas other than the ionosphere, or
No,
Yeah,
the
that'd
ionosphere
ideal.
gases are fine.
Well,
clouds, for example?
yeah, like a
Wait,
satellite
radio
in
wave-
your dish. Like if there's cloud cover over, you don't get the satellite. You don't get the reception.
At least you get a little bit less.
It
But,
probably bounces off.
you
and goes
can-
back.
But the thing is, you can ionize gas here on Earth in a lab and then replicate the same thing. So you can replicate the reflective properties of ionized gas in a lab. That
So
is a
can we
known.
demonstrate or not?
Can we what? Sorry.
Can we demonstrate what's happening in the atmosphere in a lab or not?
I'm pretty
Oh, yeah,
sure we
so
can
we-
demonstrate reflecting of radio waves on ionized gases. Yes.
Yeah, of course.
We
Yeah.
can link the paper in the chat.
I mean, it's really.
Yeah,
Taylor,
really. I
Taylor, I
love
sent you a
reading.
video. Oh, I'm sorry.
No,
I'll take it. I sent you a link to the fishbowl nuke blast in 1962. No pressure.
Oh my God! I was just looking at that today. I just was looking at that the fishbowl, the one where they shot it up in space, and to see if they can clear a space out of the Van Allen belt so the spaceship can go through. That's what they're trying to do. They're trying to move everything aside to see if they can move all the fucking radiation aside so we can fly through it. Wow! I can't believe you just said that. I just watched it. Me and my girl like 30 minutes ago.
Yeah, I
So
think
you tell me they're letting off nukes everywhere just so they can punch through the ionosphere with all these satellites and.
I'm sorry. Yeah, there was something about like they were talking about trying to get through the Van Allen belts, and they were thinking, okay, how about if we just throw a nuclear bomb up there and it'll like shoot all the ionized or like all the fucking radiation away, and we can punch through that hole right there. And that's why they tested it. I think that's why they tested it at least.
Turns out they were just trying to punch a hole in the ceiling.
Yeah, exactly. But nothing broken came back down though. Like if you punch a hole through a ceiling, usually you have like particles coming down on you, like fucking. Well, you had particles from the bomb, but you didn't have like roofing shingles and stuff falling on you or glass or whatever the firmament's made of.
Water.
I mean, if I throw a fucking M80 at my window, it's gonna explode outwards. None of that glass hit Earth.
You think? I suspect why we don't have any uncut videos from Earth to far enough away is because of the firmament.
Okay. Well, what's the firmament made of?
Great question.
Plasma.
Yeah, it could be maybe some of these gases where it gets so cold it becomes like vapor to liquid to hardened ice.
But wouldn't
That
you see
actually
that
happens
danger?
sometimes. That actually happens sometimes. That something becomes liquid, gases becomes liquid, and then they become ice. You know what happens then? It's either raining or snowing. It's not just freezing to a dome.
Yes, and there might be acid in the rain too. Depending on. But that's pollution. Never mind. It's another story altogether.
Oh, where's all the helium up in the sky? It's cold.
No, it's in the Earth pretty much, right? Most of it.
Helium's inside the Earth. The lightest gas is inside the lowest point. Okay.
Well, it expels from there and goes up. Yeah. I mean that's what.
Most of the helium is created inside of the Earth due to atomic decay.
Yeah, exactly. Yep. It's just pretty much outgassing. It's outgassing. And the outgas in this circumstance is helium.
And it's piling up or being collected in gas fields below the Earth. And when we suck the gas, it's fossil gas out of the Earth, we also get a lot of helium with it, and that can be separated.
Yeah, it's lighter, so you can separate it. Sure, easy.
Maybe back to the situation where you did not understand the difference between molecules and atoms. So helium is an atom. It can only be created by splitting other atoms or ripping something out of a specific atom. So, for example, if one atom becomes another atom, but plants, chemical processes, all that cannot do that. They only can combine atoms to new molecules or change molecules back to their atomic parts, like CO2 or water. CO2 is changing carbon and oxygen to carbon and oxygen, or together it's CO2, and water it's hydrogen and oxygen.
Yeah, but when you ram two together, like, okay, you got this explosion and you got all these particles. When they ram together, I mean, then when they hit each other and explode, they turn into other. Depends on how fast they're going, I guess. But yeah, that's another way for them to turn into other particles.
And you know how you can kind of reproduce or demonstrate, for example, that you create carbon to carbon dioxide by, for example, burning something, by burning graphite, like the thing in the middle of a pencil. Or if you burn a diamond, if you make a diamond hot enough, you get carbon dioxide and nothing else. So if it's with oxide.
Yes, and you can actually make it disappear. If you put enough heat to it, you can make a diamond just disappear. Like it'll just gas out and that's it.
I mean, it's converted to carbon dioxide, yeah.
Yes, yep.
But that is not creating, it's creating a gas because before it was a solid. But it's not that gases are permanently created down here on Earth and then are all going out of the Earth. There is a part like the outgassing, like ancient decay that happens or a chemical process that happens inside of the Earth. And there is fossil gases coming out of the Earth. There is also CO2 coming out of the Earth. There's methane coming out of the Earth. There's also helium coming out of the Earth. But it's not that big amount that it would explain all our air, or all our atmosphere.
What I don't get. Good point. Go. Okay, sorry. Go for it.
There's certain gases. Are you saying there's gases escaping in the atmosphere?
Yes.
Yeah.
For example, the thing is why we still have an atmosphere is because of our magnetic field and the gravity. But other planets have also
hydrogen.
Again?
Hydrogen.
What?
Yeah. I think hydrogen is the one that escapes most often, right? I think. Yeah. I might be wrong though.
Yeah, it was saying about 60 tons a day.
Yeah.
Hydrogen and helium, yeah.
Yeah, the helium. What the real question is, who is the first person that even thought about this to capture? Like, how the hell? I mean, this was back in the day. Like, did someone have like a bag and they're like, or it wouldn't be a bag, it would be like a goat splatter or something. Like, hey, there's some gas coming out of here. How did we capture it? I mean, the true question is, how the fuck did we even figure out how to do this?
They've been doing this back since early France.
Somebody
Yeah, I
told me
know.
before that the hydrogen and helium levels are actually decreasing because they're like escaping, but actually the hydrogen and helium are increasing in the atmosphere.
I know. So whoever told you that was wrong.
So you know what is
that.
funny, because you're asking like how did we capture that stuff? Do you know why helium is called helium?
Oh hell, so it came from the center of the Earth, and we ummed it.
Because of Helios, bro.
Helios.
Yeah,
Man, I wish we had
Helios,
that
because
crazy
of the
soundboard.
sun. Because of the sun. Because in the late 1900s, so 18 something, they already knew about spectroscopy. And sorry, I got a call. People already knew which materials are causing which absorption lines. And when a physicist was looking to the sun's corona during an eclipse, he found an absorption line that he did not know from any material. So that unknown material was then called helium because of the sun and the absorption line in the sunlight, Helios. And I think 20 years later or so, or let's say a few years later, they then found helium in fossil gas resources and could then separate it and reproduce the absorption line of the sun with the helium.
Yeah, it's a hard thing to replicate, but yeah, it's crazy the whole way that came about. You know, I mean, imagine being like, how do you even make a sensor that would even know what helium is? That's the thing. Like, that's why I would have loved to have been back there in that day. Like, all the smartest people at that time were thinking and trying to, yeah.
Let me interject with a little clarification question, okay? So just to make sure, I'm not really familiar with this topic, so I'm just asking: would it be possible that someone trying to apply this method would look through the atmosphere and through the helium existing there, and would by that introduce an error which would obtain this absorption line Snooze talked about before? So you look at an object through the air which contains helium, and then is it possible that there stems a misreading from that?
Yeah, it could be possible. Yeah, it could be possible. Yeah, it could be possible. But there's very little helium in our atmosphere. So
yeah, there's something like 0.00001% of helium. It's not affecting any spectroscopy. Yes.
Yeah, if you were looking at us, you wouldn't be able to read it. If you were doing spectroscopy like on Mars, you wouldn't be able to see the helium off our. Well, you might if you had a gauge that's sensitive, but.
So the absorption line of helium from the sunlight is really clear, and you won't have that directly due to the atmosphere. It could have been possible, but they thought it's coming from the sun, and they were right in the end. Because nowadays we can kind of see the actual difference if we do spectroscopy in high altitude or if we do spectroscopy in satellites also. We can actually measure
that's the thing that makes the web so special, is because it has the spectrometer.
Did y'all hear what I said earlier about the hydrogen and helium increasing in the atmosphere?
Yeah, this is what the whole conversation.
Okay, yeah, I was there dead zone. Sorry.
Okay. That was good. It was a good question because it definitely spurred us to this point right now, and because it's a good question. I mean, plus, just the one thing that messes with me is just how did they make the sensor? How do they even know how? The sensor part of me that's crazy.
The sensor was the spectroscope.
Yeah, I know. But how did they realize? Okay, purple is violet is gas. This is that gas. When they're in together, when they mix together, they make this color. That's the crazy part. I think it happened. I'm not saying it's not true.
Well, yeah, the whole thing with optics and prisms. Sunlight could be broken into a rainbow, and if you take any one color of the rainbow and put it through a prism, you don't get a bunch of new colors because the red is monochromatic.
Yes, it's
but that's not how spectroscopy works.
No, that's not spectroscopy, but that is the evolution of how spectroscopy was developed.
Yes, but I just mean like many people do misunderstand like, okay, the sun has a specific color, so we know what it's made of. That is not the case. The sun has specific gaps in that color, so we know what it's made of. So it's more like the blocking of a very specific frequency that we then can identify different gases. So if you heat up iron changes color. If it's hotter, it's more closer to white. And that is with everything. Like if you burn something, I mean, there are flames with some colors, that's definitely true. But the sunlight itself is just created due to the heat. And then the question is like, where is a gap? And if you have a prism and you spread that prism on your table and you separate all the different frequencies of sunlight to this rainbow, you see actually lines in the rainbow. You see a gap in the rainbow. There is a black, not really black, but it's a darker line. And this darker line happens on a very specific color, and that is an absorption line.
Why this keeps getting repeated, I don't know.
Ruhif had first asked Dr. Heffron if Dr. Heffron would be willing to get a real theodolite and do those measurements, and Dr. Heffron said no. So then Ruhif says, well, when I send out... What's that?
If you send me your method, I'm friends with him on Discord, and I can send it to him and tell him to accept you as a friend or whatever.
Oh, cool.
And maybe if you send me your method, he'll get excited about it and think about business, and maybe then because he's probably dealing with all these crazy globers who are like lashing out, so he's probably skeptical to like add anybody because people are crazy. So if I send him your method and say, hey, this guy's really trying to repeat it, then he might accept it, and then yeah.
Wait. I mean, see, this is the one thing about like crazy globers. I mean, seriously, I don't call you guys crazy. Like, seriously, there's stuff I learned from you guys and stuff you learn from me, but are you guys shut off from learning or what?
No, I'm just talking about the ones that are trying to that there's some.
Oh, you mean the outliers? You're talking about the outliers of globers. Just like, there's outliers of flat earthers, outliers of globers. Okay, I got you.
Anti-flares, yeah, I don't know.
That would be like atheist. That would be the atheist. That would be like the atheist of the shape of the earth. Yeah.
No, dude, talking about people that are like blowing up his email, sending him a bunch of stuff, trying to get a hold of him, trying to send all kinds of contacts to him to get
people do that for
little clips that they can put in their videos and stuff like that. So.
Oh, so you got a lot of fishermen in here looking for stuff that's really not. They don't. I don't even think they really give a fuck about the shape of the Earth. I think they just want to get clicks, or they want to like cause havoc. I guess that's what it. Yeah. I guess. Oh yeah. There's assholes out here.
Oh yeah, you better believe there's people trying to infiltrate circles.
I don't think infiltrate. They just want to feel special, you know. I want to feel special about what this idea I have, and like, okay, this guy, I can fucking maybe get a couple views from him if I say this or that, and yeah, that's stupid.
Well, they're planning to send people out to his house. I think Ruhif, he's in here.
Well, I like Ruhif. Ruhif's a good guy.
No, not his house, his neighborhood. Just so he can measure angles to the mountains from that general location. However,
Ruhif said that
his house? Ruhif said that since Dr. Heffron himself got a theodolite and measured those, that he doesn't have to send a surveyor out there anymore.
Okay.
Yeah.
We've been through this. He can go do the celestial theodolite in his own backyard. Doesn't need to go booking surveyors to go onto someone else's property. This is ridiculous. And why this keeps getting repeated, I don't know.
Ruhif had first asked Dr. Heffron if Dr. Heffron would be willing to get a real theodolite and do those measurements, and Dr. Heffron said no. So then Ruhif says, well, when I send out a surveyor to your neighborhood, or neighbor, or whatever, because there's public, it's public, the roads are public, and there's publicly accessible survey markers there that surveyors go to, and they have the right to go to. So Ruhif was going to send a licensed surveyor out to that public marker on public property to measure the angle to those locations. But then Dr. Heffron actually measured those himself and reported the numbers, so Ruhif said he no longer needs to do that.
Yeah, and what do you think? What would be, if you were to trust a side, would you trust a side that doesn't want to use the tools that are actually made for the job, or the one that wants to say those tools don't work, without proof that they don't work?
What?
The statement's more or less. Yeah. So the question of the theodolite is primarily about, like, yeah, it's a tool. Yeah, it works. Should it be used over such long, vast distances? Probably not. So it's the right tool for the right application.
Yep.
However, if you look at the survey grids, you will find that the surveyors did, in fact, especially in Colorado, take a whole lot of long shots with their theodolites going from mountain peak to mountain peak. If you actually look into it, that is what they did. The professionals actually surveying, accurately measuring the heights of mountains, did do 10, 20, 30, 40, 50 miles to a shot.
Didn't they also do those with transits, though? Then could we say the transits are accurate?
They used theodolites, the ones that they always used. Yeah, they've been using the kind that you can do a face left, face right reading since the 1800s.
Okay, so I thought the 1900s had the transits.
Well,
so the 1800s had like the 300-pound theodolites, right?
The transits have always been around because they're a lot cheaper to make, they're a lot lighter, they're a lot easier to transport, and they're completely sufficient for like building sites and stuff. But for actual geodetic surveying, they've been using face right, face left capable theodolites since the 1800s.
I got you, but those face left, face right theodolites are like hundreds of pounds. You think that's what they're using for all these measurements?
All the geodetic surveying, yes.
Okay, well, you need to prove that.
Anyone can Google it. I mean, I wasn't around in the 1800s. All I could do is Google it and find the records and the photos of these.
So what did they use it for then? That was a big hit back then. The transit was a big hit back in the 1900s. What did they use that for?
Building, maybe like construction sites, maybe city blocks where things weren't really that important.
Okay, things that aren't important. Well, where'd you read that?
I'm giving you my opinion based on my understanding of the accuracies of the different instruments.
No, but they still use transits for stuff like measurements in the 1900s, in my opinion. So now we're going against opinion, so we need to prove it. That's exactly what I was about to say.
Yeah, prove that. Show me what they were using a transit for in the 1900s.
Well, I think you're the first one that made the positive claim that they weren't using them.
Well, you made the claim that they were. How could I prove that they weren't? I mean, I could consult 5 documents that did not say.
I'm just wondering how you say that.
Well, I'm making a claim to the negative that they weren't. I could cite 5 documents that did not say they were.
To say that they weren't using it is a claim.
Well, you're making the positive claim that they were using them, so all you have to do to invalidate my claim is find
That's a rhetorical question. I said, weren't they using transits in the 1900s to do these same measurements?
Not
that was a question mark, and you said no.
Not for geodetic surveying, because.
Okay, well, that was the claim. That was the first claim that was made.
Okay, let me look it up.
Okay, we'll figure it out. I'm sure they felt really passionate about their transits, that they worked hard to calibrate. I'm sure you know what that feels like, Jesse. To say somebody's not like doing it right, it probably sucks.
Personal.
So Jesse Ramsden came up with the great theodolite in 1787.
Was that like 400 pounds?
Looks like it might have been.
Yeah.
The theodolites that were being used in the Great Trigonometrical Survey in India in the 1800s, under George Everest's team, for whom Mount Everest was named. Those were like 1,600 pounds each.
Right. Crazy.
And they actually raised those up to the top of 70-foot towers so that they could get a better line of sight and get their line of sight away from the surface.
I heard they also did evening and morning shots, like early morning shots. But I can't find the measurements for that. Like, I can never find the raw data.
Yeah, I don't know if those records survived. I don't know, but the Royal Society of... Hold on, let me look. The Royal Geographical Society of London would be the place to ask. I actually sent them an email or whatever their contact form on their website was and asked them for a better resolution picture of the triangulation map for measuring Mount Everest, and they sent it to me. So it might be worth reaching out to them and asking them if the actual theodolite measurements from those triangulations are available.
I mean, I don't think it's worth it. Maybe you do.
Well, you mentioned that you were interested in seeing the actual measurements, and if I understand correctly, and that I'm just saying that would be the most logical way to get them if they're available.
Yeah. Well, like, people have mentioned the measurements, and so in like response, I'm like, oh well, where are those measurements? And then they don't have them. So that's kind of what I mean. But
There are some measurements for other triangulations in the United States from the 1800s. Not the individual minute-by-minute measurements, but the averages of like measurements for all day or something. Because they'd be like measuring all day, and then they'd make an average of it.
wow.
And they literally have these large tables showing observed angle from this point between this other mountain point and this other mountain point. They give the distance and the angle and everything. Oh, that's right. I was going to text you my observer location and target location for my proposed star rising timing event.
Okay.
Taylor, just a quick question. Since we're on the topic of science, are you familiar with? I'm pretty sure you've become familiar now with the National Geographic and PBS specials.
Somewhat.
Did someone show you how they deceive the public?
I've seen it myself.
Wow.
They said all you need some carbohydrates and some nucleotides and amino acids, and boom, you got life. Couldn't believe it.
I think he's talking about the helicopter.
Yeah. Are you familiar with the National Geographic Earth curvature video that they have 6 million plus views, and then the
No.
PBS? No.
I've heard about it, but I haven't watched it.
Okay. So essentially, they were using an asymmetrical flag, and they were lying to the public, saying the bars were going below the Earth curve. And then in the PBS special, using Stephen Hawking's, it was season 1, episode 6, Genius, where they deceive the public once again. PBS, they use studio editing to try to convey that Earth hiding a helicopter. Oh, sorry, the Earth's horizon hiding a helicopter, but they were caught.
Measure out if that was even like the amount of distance they would need to hide a helicopter.
Yeah, they got the math wrong as well, supposedly. That's pretty sad that PBS and National Geographic would have to go to that level.
That is sad.
Can you imagine all the students that had to watch that in class?
Why would they even have to lie if it was just what it is? They shouldn't do that because that makes them look bad.
Yeah, using so-called science. So essentially, they used pseudoscience on the unsuspecting public, innocent
Okay.
children. Yeah.
There, I texted you all the information for my planned star occlusion tests there, Taylor.
Okay, I'll send it to Dr. Mike and Alan.
Thank you. I'm going to put it in a public chat, too, in case anyone else is interested.
Okay.
And since both endpoints are in public locations, I've got no problem sharing the latitude, longitude.
That'd be great. The more the merrier.
Definitely.
Yeah, remember whenever I went to do my reading, I talked it all out with you to make sure it was correct and stuff.
Yeah,
That helps.
definitely.
I just finally got home from work. Can you believe?
That is one long day.
Tell me about it.
Well, I've ordered an adapter for connecting my night vision scope to my telescope, and I already have an adapter that hooks my cell phone to my my night vision scope. So hopefully I'll be able to see that star, even though it'll be a little dim because it's low on the horizon, and maybe I'll even be able to see the mountain. Oh, the moon's going to be in the sky. Oh, but it might not have risen yet. That'll be good if the moon hasn't risen yet.